What's up, everybody? We're going to look at absolute value word problems. Hope you're doing well. And we're going to work in the order that you see, as always, number 1, number 2, number 3. But listen, no matter which problem we're on, we've got some key tips, all right? This is the key to doing any absolute value word problems, all right? Let's look at number 1 here. Convert equations to number line solutions and vice versa. The bottom line is this. Here's the equation. Here's what it means on a number line. And this works both ways, all right? So whatever number is here, you take the opposite of it. So -3, we're going to talk +3. That's the halfway point, the middle point on your number line, all right? We're going to take this number here, what the absolute value equation is set equal to. That's going to be your distance from your halfway point, all right? So to highlight what we're talking about right here, so back we said that our halfway point is going to be the number 3. And then we said whatever the absolute value equation is set equal to, that's our distance from the halfway point. So we're going to move 5 in this direction. We're going to end up at 8. And we're going to move 5 in the negative direction and end up at -2. All right. And look at this. Our solutions, if we solve that equation, our endpoints, those are the solutions. All right. So this is always going to be your halfway point. This is always going to be your distance from your halfway point. And your solutions are always going to be your endpoints. All right. Blah, 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 Tom. Show me in practice. All right, let's get to number 1. This is a true story, by the way. Earth gets as close as 91.4 million miles to the sun and as far as 94.5 million miles. Represent these values on a number line and in an absolute value equation. All right, we said that, okay, so let's represent it on the number line first. It gets as close as 91.4 million miles. All right, so that's the lower number. All right, that's one extreme. I know these are endpoints because it's talking about the furthest and the closest. All right, the furthest it gets is 94.5 million miles. And way to use your number lines that you already set up, Tom. All right. That's right. We're going to keep rocking with the top. All right. Now, so what's our middle point? Well, in this problem, we just need to average out the two extremes to find our middle point. All right, so 91.4 plus 94.5. I'll take it real slow on my calculator. I'll hit enter. All right, that total divided by 2. I'm averaging out the 2. All right, 92.95. All right. Boom. So so represent these values on a number line. All right, we've done that. And in an absolute value equation. Well, look at this. You need to write an absolute value equation. You could go like this right away. The absolute value of something equals something. All right. And guess what? One thing that we didn't talk about, look at the absolute value equations. Just put x there. All right. Again, so this is your structure. We already have the structure. Now we just got to fill in a few key pieces. What did we say goes here? The halfway point. All right. 92.95. Okay. And remember, we do the opposite. So minus 92.95. All right. What goes here? The distance from the halfway point. All right. Well, we didn't figure out yet. Let's figure out this distance. And that is simply 92.95 minus 91.4. Remember, absolute value is all about distance. Doesn't matter if it's positive or negative. So just another tip for this spot right here, just whatever the distance from the halfway point is, just represent it as positive. Don't worry, did my calculator say positive or negative? This value here, we're always going to write in as a positive. All right. Okay. Boom, and guess what? We're done. We represented these values on a number line and in an absolute value equation. All right, number 2. The shortest person ever, and I believe we're talking about adults, all right, was 2 feet tall, rounded to the nearest foot. The tallest person ever was 9 feet tall, also rounded. However tall or short you are, could be a lot worse. Could be a lot better too, I guess, but could be a lot worse. All right. Represent these values on a number line and in an absolute value equation. Hey, I wish I was taller, but you know what? I'm not. So I'm funny. Maybe. I don't know. Maybe not. Now I got problems. Well, I could do these. I could do these absolute value problems though. So let's go. All right. The short. Okay. These are the extremes, the endpoints. All right. Represent these values on a number line and in an absolute value equation. All right. Well, here's my number line. Oh, Tom, draw a straight line, bro. All right. There it is. 2, 9. All right. So how do I find the middle point? Well, I add up 2 and 9 and divide by 2. That's how I get the average. We're going to get 5.5. Here we go. Okay, so now boom, that's it. We represented these values on a number line, just like that. Now, an equation. Well, hey, without even thinking, set up your structure. Absolute value equation, boom, that's your structure. What are we going to drop here? The halfway point. All right. Positive 5.5, so I'm going to throw in negative 5.5. Just always do the opposite there. Okay. What's my distance from my halfway point? Well, calculator, 5.5 minus 2 will tell me my distance is 3.5. Always a positive over here on the right side of the absolute value equation. Otherwise, you have an equation that doesn't work. All right. Boom. Guess what? We did it again. We represented these values on a number line and in an absolute value equation. That's how you know you're done writing an absolute value equation. You have a number here, bing, bing, you're done. All right, number 3. A friend is 500 feet away, snowmobiling toward you. Hope they're not too close. Your friend's distance, d, after t seconds is given by the equation all right, they give us an equation. Let's write it down because we're going to have to work with it. All right, 500 minus 12t. All right. Okay, at what times? So they're asking us to solve for time. Well, they better give us d then because we only want one missing letter and we can solve for it. Sure enough, they say at what times is your friend 140 feet from you? That's a distance. All right. So 140 equals 500, absolute value of 500 minus 12t. All right, now it's just a typical absolute value equation. In fact, let's put it in the form that we're comfortable with. 500 minus 12t equals, absolute value of that expression equals 140. All right, now we can write our two equations. Split, all right, split screen. Not really, but splitting the screen. 500 minus 12t equals 140. And then the other absolute value equation we write is 500 minus 12t could also equal negative 140. All right. We work this out. We start with the left side. This 500 is a positive 500, so we're going to subtract it away from both sides. And we're going to get negative 12t equals negative 360. T equals, if I divide both sides by negative 12, 360 divided by 12, 30. All right, so 30. And by the way, you might be like, how could your friend be 140 feet away from you at different times? It says times. Well, imagine it like this. Here's you. Here's your friend snowmobiling toward you. Okay, at this time, at time 1, they could be 140 feet away from you, but then they're going to keep snowmobiling, and then at time 2, they could also be 140 feet away from you, right? Remember, absolute value doesn't care about positive or negative, just total distance. All right. So after 30, it's going to take your friend 30 seconds to be 140 feet away from you. And let's see what the other answer is. If we subtract 500 away here, we are going to have negative 640, and we're going to divide by negative 12. T 640 divided by 12. 53.33 repeating. All right, I'll round to the nearest hundred. All right, these are our times, seconds, seconds. All right, that's when your friend will be 140 feet away from you. One time in front of you, one time past you. All right, number. So remember, just by the way, write the equation down, plug in the one extra piece, and solve like it's a normal absolute value equation. All right, number 4, 48% of high school students surveyed nationwide like Khalid. The margin of error was plus or minus 7%. All right, let's get that rocking on a number line. As soon as I see that information, that's my instinct. Let's go with it. 48% is the survey with a margin of error of plus or minus 7%. We go 7% this way, we end up at 55%. Go 7% the other way, we end up at 41%. All right. Write and solve an absolute value equation to find the lowest and highest possible percents of students who like Khalid. Well, we found it logically with drawing a number line, but what if we did have to write an equation? Well, let's go to what we know. Start with this setup right away. All right. Now, what did we say always goes here? Always goes here. The middle, the halfway point. All right, and the opposite. So minus 0.48, let's say. And then what do we say goes here? Always the distance from that middle point. We traveled 0.07, because I'm not talking in percents, I'm talking in decimals, because it's easier to work on math problems in decimal form than percent form. Boom. If we solve this equation, we would get 41% and 55%. And here, watch. X minus 0.48 could equal 0.07. X minus 0.48 could equal negative 0.07. We add 0.48 to the other side, we get 0.55. We add 0.48 to the other side, we get 0.41. Boom, just solved it. Is it fair to claim that half of high school students like Khalid? Yes, because half, 50%, falls in this window. All right. Number 5. Ooh, scandalous Deflategate scandals. Tom Brady is the GOAT. That's the bottom line. And that's coming from someone from the New York, New Jersey area. All right. But he's just that good. Got to give it up to him. All right. The recommended weight of an NFL football is 13 psi. The actual psi is allowed to vary by 0.5 psi. All right. So look. Boom, right away. 13 is what we're going for. 13's in the middle. If we vary by 0.5, we could get up as high as 13.5. We could get down as low as 12.5 psi. Write and solve an absolute value equation to find the minimum and maximum allowed weights. All right, so remember we moved 0.5 in this direction, 0.5 in that direction. So that write an absolute value equation, no problem. I know I'm going to do that every time. I know I'm going to drop my midpoint right here, opposite sign. And I know I'm going to drop my distance to my endpoints right here. And that's always going to be positive, so just 0.5. Okay, I solve my two equations. It could equal 0.5. X minus 13 could equal negative 0.5. All right. And we are going to get x equals 13.5 and x equals 12.5. So here's my max allowed weight. Here's my min allowed weight. Okay. B. Tom Brady started a game with a ball that was 12.6 psi. All right, that's about here. That's good. Due to the heat, the ball's pressure rose by 0.8 psi by the end of the game. Was the final pressure acceptable? So 12.6 but it went 0.8 higher. That gets us to 13.4. That's here. That is, and remember, this whole thing as a whole is the acceptable range. Tom Brady is good to go. Get off his back, cheaters. Yes, it was acceptable. Did I say cheaters? I meant to say haters. All right. Boom. There we go. All right. Hope this was helpful as always. Hope it demystifies absolute value word problems. Hope it can help keep building your math skills, your foundation. Remember, it's all brain food. You're just making your brain stronger for whatever you're going to do in the future. Great analytical and quantitative skills working through all these. If we can help you out, let us know. If not, keep crushing it on your own and catch you in the next video. All right. Have a great day in the meantime, or get right to a next video. All right. Take care. And now watch me sign out.